Hello everyone, welcome to Equal To, and this is the 8th episode of our Is Matter Around Us PR playlist. If you haven't watched the previous 7 episodes yet, please go and watch that, don't miss that out. Now in this video we are going to see about the separating methods. So we know what a mixture is, and a mixture can be separated into its components, and that lets you to analyze or study that individual components. So let us say we have seawater for example, and seawater has sodium chloride dissolved in it. We know that obviously. Now to study the composition or to study the properties of sodium chloride, you first have to separate sodium chloride from seawater, right? So since seawater is a mixture, we have to separate sodium chloride from it, and that is only when you will be able to study the properties of sodium chloride. Now that is what we are going to see in this particular video, which is separating methods. So the methods that you can use to separate mixtures. So when it comes to heterogeneous mixtures can be separated into their respective components by simple physical methods. So by simple physical methods they mean hand picking, sieving and filtration. So hand picking is just literally what it means. You pick your solute particles, or you pick your components of mixture apart with your hand. You just pick it out with your hand, and that is a separation method. And the next thing is sieving. Sieving is you would probably do with rice to separate adulteration from it, and that is one process you can use to separate mixtures. And also from flour, you use sieving to clean up flour as well. Okay, and another thing is filtration. Filtration is also a method, separating method that can be used to separate components of a mixture. Now moving on, we have activity, and with that activity we will also be learning a method of separation. So what they are telling is that they want you to separate the dye from ink. Okay, so ink is basically dye dissolved in water. So you have to separate that dye from that water. That is your task. So what you're going to do is that you're going to take a burner, you're going to have a tripod stand over it, and you're going to light the burner. You're going to place a beaker, and that is filled with water. Now what you're going to do is that you're going to add a watch glass over this beaker. So watch glass is nothing, it's just a glass plate like thing, and you're going to place that watch glass like a lid to that beaker. It's placed like a lid, it's over the beaker. Now what you're going to do is that you're going to drop few drops of ink on that watch glass, and you're going to heat this beaker. You're not heating the ink, you're not heating the watch glass, but you are heating the beaker. So what happens is that the water in the beaker heats up, and those vapors they go and heat up the watch glass, and you will observe vapors coming from the ink that is present in the watch glass. So this would be your observation. So what we get is that we have volatile component, which is the solvent here, which is water. So water on heating evaporates. Water is volatile and it is the solvent in this case. Now what is left behind is the dye. Dye is non-volatile solute in this mixture. In this mixture, that is ink, you have the solute, which is the dye, which is non-volatile, and you have the solvent water, which is volatile in nature. Now since we heated the mixture, the water turn into water vapors and evaporate, and we are left with the dye that is non-volatile in nature. Now this is a process that we call as evaporation, which we have learnt already in the previous chapter. I hope you have watched that video and you remember what evaporation is. So this is evaporation, and we use evaporation to separate dye from the ink. So it's a separation method. Okay, now moving on to the next activity. Now this is one separation method that we have learnt. So hand picking is a separation method that we use for heterogeneous mixtures, right? Only heterogeneous mixtures you will be able to hand pick. In a solution of salt water, you will not be able to hand pick salt particles from it, right? Obviously, it's absurd. You would never do that. You cannot do that. Now, only in heterogeneous mixtures, sieving, hand picking and filtration would work. Now, for homogeneous, those things won't work. Or homogeneous like mixtures as well. When the solid particles are small enough, you will not be able to pick it. So that is why we saw this evaporation. And the next thing is, it also comes with an activity which is separate cream from milk. Okay. So you would have seen paneer, I hope you know paneer, that is extracted from milk. Okay. So how is that done? That we'll see now. Okay. So what you're going to do is that you're going to take some milk and you're going to use a centrifuge on it. Okay. Now what is a centrifuge? You might be confused a little bit, or well, if you know what a centrifuge is already, but let me say, instead of a centrifuge, you can also have a milk churner. Milk churner. I hope you know what a milk churner is. The one here, the brown one, which is in wood. You probably have this in your home, which you can use on milk and churn it. You are going to rotate it to and fro with your hands, and that what will it do is that after doing it for some time, you will be able to see the fat getting settled down. Okay, because fat is denser when compared to water. So milk is basically fat and water, right? There is also some other things in that, but basically it is fat and water. Now when you churn the milk, it's forced to its sides, and now we'll be seeing that in detail in the slides, but I'm just telling you, when you do that, it gets separated. So this is what we call as centrifugation. Okay, so what is it? Sometimes the solid particles in a liquid are very small to pass through a filter paper. So in case of milk, we have fat content in milk, we have fat in water. Fat is actually solid, but it doesn't pass through the filter paper. It's too small for it to pass through the filter paper. So it doesn't pass through. You use a filter on milk, nothing happens. So when that happens, you have to use centrifugation. So centrifugation works on the principle that denser particles are forced to the bottom of the vessel and lighter particles stay at the top when spun rapidly. So when you spin the particles of milk rapidly with the churner, the denser particles are forced to the bottom of the vessel and the lighter particles, which is water, just stays above. Now in this case, you would be able to take the water away or take the fat content away. So this way you can separate the cream from milk, and this is what we call as centrifugation. But there are certain applications to centrifugation that are very important to us and that we have to learn it. So the first example of centrifugation is that we can use centrifugation in lab tests. Okay, so for medical lab test, you give a blood test, you give a urine test. In those cases, they have to separate some materials from it, some contents from it, some components from it. In that case, they place your blood in a test tube in a centrifuge machine. They place it in a centrifuge machine and they turn it on and it spins rapidly. It spins your test tube rapidly. That forces denser particles to get down, settle down, and lighter particles, lighter things to float at the top. And then they'd be able to easily get away with the lighter ones and test the denser ones that are settled. So okay, so this picture here is a picture of centrifuge machine which is used in labs to take blood tests. And another example which we use in our day-to-day life, that is an application of centrifugation, is washing machine. So in washing machine, you put your clothes, it gets water, it mixes it up very well, and to dry your clothes out of water, it spins very fast. This we know. In washing machine, the tub spins very fast, and since it spins very fast, centrifugation happens. So the denser clothes, they settle down, and the lighter water, it comes out. Okay, so this is how centrifugation works in washing machines to dry your clothes. Another application is what we have just seen, extracting cream from milk or paneer from milk is another example for centrifugation. Now moving on, we have another method of centrifugation for a specific type of mixtures, which is immiscible liquids. So what is immiscible? Immiscible is generally when two things don't mix together, we call it immiscible. A very good example could be oil in water. If you see oil in water, oil just floats in water. It doesn't get mixed together well. So how do we separate these type of immiscible liquids? That is what we are going to see now. So we have an apparatus called a separating funnel, and I have a picture here where I have marked out, actually this is just a picture, I didn't mark out, but these are the parts of the separating funnel. So the whole thing is a funnel, and we have kerosene and water mixture here. So these are two immiscible liquids. Kerosene oil doesn't mix with water at all, so they are immiscible. And we have a stopcock, which is like a tap you can use to get the water out of it. Okay, so that is a stopcock. Now what you have to do is that you have to let this separating funnel stay there undisturbed for a while first. You have to let it stay there undisturbed for a while. So what will happen is that the denser fluid, the denser liquid, it settles down, and the lesser denser one, depending on the densities, they form separate layers. So water is denser when compared to kerosene, so water is settled down and kerosene is floating over water. So this kind of thing happens. Now after this, it's kind of obvious quite. We are just going to open the stopcock, which is the tap, and you're going to let all the water down, and you're going to stop it just when every single drop of water comes out, and you're going to stop it right there when kerosene is at the bottom. So that is what you're going to do, and that is how separating funnel can be used to separate two immiscible liquids. Now, few applications of separating funnel is obviously the one that we already seen, which is separating oil from water. Oil and water, they are immiscible liquids. Whenever you come up with immiscible liquids, separating funnel is the way to separate them. So oil and water, it can be separated using separation funnel. And another example which is used industrially is separating iron from the iron ore. So what it happens is that they put iron ore in the furnace and they heat up it very well. What happens is that the lighter slag is removed from the top by this method and leave the molten iron at the bottom of the furnace. So when it melts really, when iron ore is melted, the impurities, the lighter ones, the slag, it gets above, and the molten iron, it is since it has higher density, it gets down in the furnace, and that is how you can easily remove the slag from the furnace, and that you will be left out with just the iron. So in this way we are using it's quite similar to separating funnel, but the concept is same, meaning denser fluids go down and lighter fluids stay above it and float on it. Okay, so this is how iron ore is extracted. Okay, so when the iron is extracted from iron ore, this is another application for separation using that technique. Now these are few separating techniques that we have seen now. There are more separating techniques that we will see in the next video, so please don't forget to subscribe and see you in the next video. If you have any questions, please put them in the comments. I'll get back to you as soon as possible. Thank you so much for watching this one. Bye for now.